In the previous video, we've just discussed on the release of an alpha and a beta particle, and we've seen the different equations that we're able to get. Now let's say we have got a gamma particle or a gamma ray to be released in a reaction. Or let's say there is a fission getting to happen, a compound gets to break. So what is going to happen? What is the reaction for gamma decay? Now for a gamma ray, we know this is an electromagnetic wave. So it is basically massless and it has got no protons. We at least assume these are negligible, they are too small, so we consider them as zero. Meaning that if I have got this compound, it undergoes a gamma radiation, it will not be changed. So I'll just put a star there, and then a gamma ray is also produced. Now because gamma ray, the symbol is more a y, let me put this as x so that it will be different. So the only difference is that this one and its original have got different energies, because this is an electromagnetic wave which is released. Otherwise it's the same compound, it doesn't change. But mostly when you are releasing a gamma ray, you release them together with beta and alpha particles. So let's say we have got, let me say, oxygen, which has got a mass number of 12, a proton number of 6, and then it undergoes a beta radiation, a beta decay, where it gets also to release an alpha particle. What we are going to be able to see is that, of course, when it releases an alpha particle, we know that, firstly, let me write, because it's undergoing also a beta decay, so a gamma decay, so we're going to have gamma rays produced, and then also let's say it's undergoing alpha decay, so we're going to have an helium atom. So I can write this is alpha decay, or I can write the helium itself with a 4 on top and then a 2. This is showing that an alpha particle is released. This is showing that a gamma particle is released. And this, we can see we have released 2 protons from the 6. How many are going to remain? We are going to remain with 4. We have released also the mass number of 4. So from 12, how much is going to remain? We are going to remain with 8. So now we need to find out what compound is this which has got 4 as the proton number and 8 as the mass number. So if you want to identify this compound, just look at the proton number on the periodic table. You see that element with a proton number of 4. That is going to give us what this compound which is going to be released is. So you are able to determine what kind of product is going to be formed after a compound undergoes different decays. Let's say it doesn't just undergo a gamma decay once, maybe it undergoes also an alpha decay and different like that. So let's say if we have got this compound Y, it has got a mass number of, let me say, 130, and then it has got 20 protons. If it first undergoes an alpha decay, when something undergoes an alpha decay, the mass number drops by 4, so it's going to now be 126. The proton number drops by 2, that is going to be 18. This is going to form a different compound X. We can check on the periodic table something that has got a proton number of 18 to see what element is that. Let's say it then undergoes a beta decay. So what is this going to form? We are going to have a mass number still the same for a beta decay, but the proton number increases by 1. So this will now be 19, and this will be a different substance Z. We can determine what this substance is from the periodic table after these 2 decays. So we now know alpha radiations, beta radiation, and gamma radiations. What are some of their properties? So when we have got, let's say, a source of radiation here, and it gets to release all the 3, the gamma radiation, the beta radiation, and also the alpha rays. What is going to happen? Let's say we are subjecting now to a magnetic field. A magnetic field. Now for, let me not say magnetic field, let me say electric field, meaning that we have got a positive, let's say we have got a negative charge this side, and then we have got a positive charge this side. What will be the behavior of these particles in an electric field? Now, firstly, we know that beta is negatively charged because these are simply high speed electrons. So negative things are supposed to be deflected towards the positive. So this is going to be it. They'll be deflected like that. And then the alpha ones, these are simply helium nucleus. These are positive, and so they'll be deflected towards the negative. Now gamma rays, because they're electromagnetic waves, they are not affected by magnetic field. So these will basically pass without being affected. These are the gamma rays. Now we can see that for beta rays, they've got a stronger deflection. And then we have got alpha rays, which have got the next high deflection, whereas gamma rays don't even deflect at all. So this is what we are going to be able to see. Now again, what will be the behavior of this? What is able to block these radiations? Because these radiations are more dangerous when it comes to the human body, so they have to be prevented. So when you have got a source of radiation here, and then you get to put a paper here. So for a paper, this one is able to stop alpha particles. So when alpha particles are coming, they'll just be able to stop on the paper. But gamma rays and also alpha ones are going to be, also beta radiations are going to be able to pass. Now when we bring again another hindrance at this point, okay, the ones in yellow, these are alpha, and then the one in green, this is the beta. So beta radiations can be stopped by aluminium block. So if you want to stop beta radiation, you need to use aluminium block. But still gamma radiations are going to pass. They will not be stopped by that. So if I want to stop gamma radiations, I have to use a very thick block of lead. So it is lead that is able to stop gamma radiations. So we see for alpha radiations, they don't have that much penetrating power, meaning that they can just be easily stopped, and like that. Okay, we can consider some other properties of these radiations. I'll write a diagram starting with alpha, and then beta, and then the gamma radiations. We can start with a definition. We know that alpha is simply helium nucleus. Beta, this is simply high speed electron. And then gamma, this is the electromagnetic wave. Now if we go to their charge, alpha rays, because these are helium nucleus, these are basically positive charge. They've got a charge of positive 2. Electrons are negative. They've got a charge of negative 1. Now gamma rays are neutral. That's why they will not be affected even by the electric field. If we talk about the ionizing power, how much can they ionize? So for alpha particles, they are 100 times greater than beta. So these have got highest ionizing power. They've got high ionization. That is why we are saying when we bring electric field, these are going to be deflected faster, and then followed by beta, and then these others will just move straight. Okay, so these have got high ionization. And then these have got low ionization, and then these have got less ionization. Okay, so meaning that where these are able to pass, they can easily ionize a substance. To ionize is to change it into ions. Now let's get to look also about their penetrating power. As we saw, these can just be stopped by a paper, meaning that for penetrating power, they have got low penetrating power. And then the beta, we saw that they could not be stopped by a paper, but they could be stopped by aluminium, meaning that they've got at least a high penetrating power, but they can be stopped by aluminium. And then gamma have got highest penetrating power, they can only be stopped by lead. Okay, now let's look at the effect of a magnetic field. What happens? So for alpha radiations, effect of a magnetic field, they are deflected by both the fields. Okay, these can be deflected by magnetic and electric field. So if you bring a magnet, they're going to be deflected. If you bring electricity, they also be deflected towards the negative terminal. And then these, they also are able to be deflected in the by a magnet or by electricity. Okay, now these gamma rays, they cannot be deflected, or they are not affected by magnetic field and also electric field. Now what are their speeds? Which one is the fastest? Alpha rays have got a speed which range from 1 over 10 to 1 over 20 times the speed of light. When you talk about beta rays, their speed can go up to 9 over 10 the speed of light, meaning that these are faster than alpha rays. And then if you consider gamma rays, gamma rays, these basically move at the speed of light. Move at speed of light c, meaning they are the fastest. So this is it for this tutorial. Thank you so much for watching. Enjoy your day.